Tonight we take a question a child could ask, what is directly above us, and follow it straight up out of the Milky Way itself. That is the strange part, because every map of the galaxy ever drawn looks sideways across the disk and leaves straight up blank. The galaxy is 100,000 light-years wide, and the bright layer we live inside is only about 1,000 light-years thick. Shrink the Milky Way to a dinner plate, and every star you have ever seen would be a film of light thinner than the china it rests on. So this is not a great ball of stars. It is closer to a sheet, and we live just off its middle. Tonight we rise out of that sheet, one layer at a time, past the thick disk, past clusters older than the Sunday, and out above the galaxy's North Pole. Someone you know is probably still awake right now, without choosing to be. Let this find them. Company in the dark is a small thing to give, and it travels well. Now let the pillow do the holding, and let each breath leave slower than the one before. Nothing above us asks anything of you. Should sleep arrive before the first layer is behind us, it has done its work. Let's rise. Beneath us now, though its shape has not yet come into view, lies the disk that has held every star we have ever named. Picture it flattened and enormous, a pale wheel of light spanning roughly 100,000 light-years from one edge to the other, so wide that even light itself would need the whole of that span just to cross it once. Somewhere inside that wheel drift an estimated few 100 billion stars, though no one has ever counted them one by one, and the true figure remains, even now, an informed guess rather than a finished tally. Within that wheel sits a far thinner region, the part we actually call home, a shallow band only about 1,000 light-years from its upper face to its lower one. Against the wheel's full breadth, that thickness is almost nothing, a sliver pressed flat inside a far larger disk. It is closer to a sheet than a sphere, and nearly everything ever seen with the naked human eye, every star in every constellation ever named and drawn, has spent its entire existence somewhere inside that sheet. Our own Sunday does not rest precisely on the sheet's center line. Current estimates place it roughly 90 light-years above the galaxy's mid-plane, an imagined flat seam running through the exact middle of the disk. That number is not a fixed mark carved into the sky. Astronomers arrive at it by tracking the positions and motions of nearby stars, and different surveys land on slightly different values, though they agree closely enough on the general picture. What matters more than the precise figure is the plain fact it points to. We are not sitting at the sheet's floor, nor at its ceiling, but somewhere in the modest space between, drifting slowly through that space, the way anything settles when it has had billions of years to find its own rhythm. That drift has a rhythm worth naming. Roughly every 30 to 40 million years, the Sunday completes one full pass through the midplane, climbing to its highest point above the disk, sinking back down through the crowded seam at the center, continuing to a similar depth below, and then turning to rise again. Set against a single human lifetime, that cycle is almost unimaginably slow, a bob so gentle it could never be felt, no lurch, no signal, nothing a body could ever sense from the inside. Yet Earth has ridden along for the whole of its history, crossing that seam something like 100 times or more, long before a single curious eye ever looked upward and wondered why the night sky wore the particular face it does. Whole ages of the planet, Whole stretches of ice and warmth and slow change on the ground passed while this quiet vertical drift carried on overhead, unnoticed, unhurried, entirely indifferent to anything happening below. And the sky wears that face for a very specific reason, tied directly to where we happen to sit. On a clear night, far from any city's glow, a faint band of light stretches from one horizon to the other, soft-edged and uneven, closer to a pale river of mist than to any gathering of distinct points. Dark lanes thread through parts of that river, quiet rifts where dust blocks the glow behind it, and brighter clouds swell in other places where starlight gathers more thickly. Generations have simply called the whole of it the Milky Way, and the name has drifted so far from its origin that it can feel like some separate, hazy curtain draped behind the true stars. It is not a curtain hanging apart from anything. It is the disk itself, the very sheet we are floating inside, viewed from within its own thickness, stretched thin and pale across the whole sky, because we are looking sideways through the greatest possible depth of its stars and dust. This is worth sitting with for a moment, unhurried. If it was somehow possible to lift entirely clear of the disk and look back down from far above, the galaxy would resolve into the shape astronomers draw in diagrams, a bright core wound through with great curling arms, compact and whole, more like a single glowing coin turning slowly in the dark than any smear of light across a sky. But no one is above it. We are inside it, only a modest distance off its center line. And so instead of a coin, we see a band, a long faint seam of light wrapped once around the whole of the visible night. Every star within that band is, in the truest sense, a neighbor, near or distant, sharing our same thin layer of space. From in here, the disk does not look small. It looks like it could not possibly have an end, an ocean without any visible far wall. Nearer the midplane itself, the crowding only grows thicker, more stars and more dust folded into the same modest thickness, though our own quiet position keeps us a little apart from the densest part of the crowd. Think, for a moment, of a swimmer floating just beneath the surface of a still lake at night, held there weightless, looking outward in every sideways direction the body can turn. From that position, the water seems to reach on forever. There is no shoreline visible to the left, none to the right, none behind. Only more dim water continuing however far the eye tries to follow it. And yet the true surface of the lake, the actual boundary where water gives way to open night air, sits no farther off than the length of an arm straight overhead. The swimmer has simply not been looking that way. Nearby the whole time, that edge only ever needed a turn of the head, not a long swim, to finally come into view. We live inside a quiet version of that same mismatch. Sideways, the disk feels boundless, crowded with stars in every direction. The eye can wander, an ocean of light, with no shore anywhere in sight. But our actual position within it, roughly 90 light-years above the midplane, tucked inside a layer only about 1,000 light-years thick, means the true edge of the disk, the place where its stars finally thin out and give way to open dark, sits startlingly close by the standards of the galaxy itself. Not close in any sense a human body could casually travel. Close only in the sense that matters here tonight, measured against the disk's staggering 100,000 light-year width, the surface above us is barely any distance at all. a short climb set against an almost unimaginable sideways sprawl. So the direction we are rising in tonight is not a sideways direction. It is not a journey further along the band of light that arcs overhead, deeper into that river of distant stars, but the other way entirely, up and out of the sheet, toward the very surface the swimmer never quite turns to face. Few ever look there, not because it is forbidden in any sense, but because almost nothing about the shape of an ordinary life, or a solar system, or even a whole civilization, looking up from a single small planet, requires reading the sky straight through rather than sideways along it. The band overhead has always been enough of a horizon to hold a lifetime of wondering. Leaving the sheet behind does not mean leaving the galaxy behind. Not yet, not for a long while. It means climbing clear of the layer where nearly all of the disk's stars, its gas, and its drifting dust are gathered together, and passing beyond the thin slab that has quietly organized almost everything visible from Earth into that soft pale band overhead. Night after night, for as long as anyone has thought to look up and ask what it was. Somewhere not far above, measured on the galaxy's own vast scale, that crowding begins to fall away. The dust thins first, then the gas, then the stars themselves grow sparse enough to count rather than to blur together into a single glow. None of that thinning happens quickly, not on any scale a single night could hold, but the trend itself is real, and from here it points only one way. Once that gathering finally thins beneath us and falls away, the wheel will no longer be something we are pressed flat inside of. It will become something we can begin, for the first time, to actually see, the way a swimmer breaking the surface finally sees the shape of the shore they could never make out from below. And once the last faint glow of that sheet has thinned away below, leaving only its edge somewhere at our backs, what is it, exactly, that waits above the surface? The climb continues, and already the crowded plain behind us is thinning into a pale seam of light. Rising this way, straight up out of the disk, rather than along it, changes more than the view. It changes what can be seen at all, because for the first time we are looking through the shortest possible stretch of the galaxy instead of the longest. Consider what that sideways glance had always meant, back when the only motion available was along the plane. To look along the plane, the way every one of our ancestors looked for the whole of human history, is to look down a corridor of stars and gas and dust that runs for tens of thousands of light years in either direction. Light entering the eye from that direction has to cross enormous distances of the galaxy's own material before it arrives, and dust absorbs and scatters it along nearly every stretch of the way. That is why the band across a dark sky has always looked hazy rather than sharp, a wash of glow rather than a field of clean points. It is not that the galaxy grows dim in that direction. We are instead seeing it through nearly the whole of itself, layer after layer, stacked for tens of thousands of light years. Straight up is the opposite kind of view entirely. Ascend from the plane, and the amount of galaxy left between the eye and open space shrinks with every year of travel, because the disk is remarkably thin compared to how wide it spreads. A climb of a few hundred light years upward can carry a traveler clear of most of the gas and dust that fogs the sideways view, even though a journey of the same few hundred light years sideways would barely register against a disk tens of thousands of light years across. Height gets a traveler out. Distance along the plane within any reasonable stretch of a lifetime, never does. That single asymmetry, thin in one direction and almost incomprehensibly long in the other, is the entire reason a map of home looks the way it does, and the entire reason no one who ever lived inside the disk could simply glance upward and see it whole. And here is something almost nobody pauses to say aloud while looking at that familiar picture. The map itself, the shape everyone pictures the moment they hear the word galaxy, the pinwheel with the graceful spiral arms curling out from a bright core, has never once been photographed. No probe, no telescope, no instrument built by human hands has ever left the Milky Way and turned around to look back at it from outside. Every one of those images, the poster on a classroom wall, the animation narrating a documentary, the slow render behind a planetarium dome, is an inference rather than a photograph. It was built from the inside, assembled by measuring the positions and motions and light of countless stars from a vantage point buried deep within the very structure, being described, then reasoning carefully outward toward a shape no eye has ever confirmed directly. Picture standing in a long lit hallway lined with doors. Look either direction along the corridor and 100 doors recede into the distance. Each one visible, each one countable, a whole architecture laid out ahead, simply because you are looking through the length of the building rather than across its width. Now look straight up. There is a ceiling only a few feet above your head, close enough to touch, and past it, almost nothing registers. No doors, no rooms, no sense of what continues upward beyond that first surface, because no one standing in that hallway has ever had a reason or a way to look through it. Every drawing anyone in that hallway ever makes is a drawing of the corridor, its doors, its length, its long receding lines, because that is the only direction offering anything to draw. The ceiling stays blank on every one of those drawings. Not because there is nothing above it, only because no one has ever drawn what they had never actually looked at. That has been the situation of every being who ever lived inside this disk, ourselves included until this very ascent. We inherited a magnificent corridor view and mistook it, reasonably enough, for the whole of the building. The spiral portrait, passed down through a century of careful astronomy, is a hard-won, largely trustworthy piece of reasoning, pieced together from radio surveys, star counts, and the patient triangulation of distances across tens of thousands of light years. It is probably close to correct, though even the astronomers who built it would say some of its finer details remain genuinely uncertain. But every part of it was drawn by residents of the hallway, squinting sideways down the doors, and never once by anyone who got to rise above the ceiling and check. Building that spiral portrait, even from inside the hallway, has taken more than eyesight alone. Radio telescopes, tuned to a specific wavelength, given off by cold hydrogen gas. A wavelength dust cannot block the way it blocks ordinary visible light, have let astronomers trace the outline of spiral arms far along the disk, well past where starlight itself fades into haze. Infrared light helps in a similar way, slipping through dust that would stop a visible photon cold, carrying hints of structure back from the crowded plane to instruments built to catch exactly that wavelength. And in recent years, a spacecraft has spent years quietly measuring the positions, distances, and motions of more than 1 billion stars, one careful fix at a time, building the closest thing astronomers have to a three-dimensional model of the disk from within it. None of these methods lets anyone step outside and look back. They simply let the hallway be mapped more precisely by feel and patient triangulation, rather than by a single confirming glance. There is one imperfect kind of help available, and it comes from a neighbor rather than a mirror. The nearest large spiral galaxy to our own happens to be tilted enough, relative to us, that much of its true shape is visible directly. Arms and dust lanes and bright core laid out in a single photograph, the way our own galaxy never can be from here. Astronomers studying that neighboring spiral sometimes use it to test assumptions about what a galaxy like ours ought to look like from outside. The closest thing to a photograph of the corridors building that this science currently has. But a neighbor is not a mirror. Its arms curl differently, its bulge is shaped differently, and every lesson borrowed from it has to be carried back to our own galaxy carefully, as a hint rather than a confirmation. None of this changes the plain fact that no observatory and no traveler has ever actually left the disk and turned around to look back at it whole. Every refinement, every added layer of radio or infrared data, every new pass of careful triangulation still gets assembled by someone standing inside the very structure being mapped, adding precision to an inference rather than replacing it with a photograph. It is patient work, generations of it, carried forward by astronomers who will each spend a working life refining a shape none of them will ever personally see from outside. That is the quiet asterisk sitting under every polished image of our galaxy ever printed on a page or projected onto a dome. We are now doing something almost nobody and nothing before us ever has done. Rising past the ceiling itself carries us out of the one direction every previous picture was drawn from, into the one direction that stayed blank on every version of the map anyone ever made. So the question returns, carried upward with us and changed a little by the climb. Past that ceiling, past the thin roof of our own galaxy. What is actually waiting there? We rise a little further, and the first thing we notice is that the sky above us does not go dark all at once. Stars keep appearing, fewer and more scattered, but present, drifting in a layer that reaches roughly 1,500 light years above the plane we call home and about the same distance below it. Astronomers call this layer the thick disk, and once we cross into it, the thin disk. That bright, busy band Chapter 1 walked us through, sits beneath us like a lit floor we have left behind. 3,000 light years from its lower edge to its upper edge. This new layer is roughly 3 times as thick as the one we started in. It is not empty up here, only calmer and far more spread out. The stars themselves feel different once we slow down and look closely. Many of them are old, some among the oldest stars in the galaxy, born long before the Sunday existed. They also carry less of what astronomers call heavy elements, the carbon, iron, and oxygen forged inside earlier generations of stars and scattered outward when those stars ended their lives. A star poor in these elements is in a sense an early arrival, formed before the galaxy had finished enriching itself. That scarcity is one of the clearest signatures separating thick-disked stars from the younger, more chemically seasoned population we left below. Motion sets them apart too. Down in the thin disk, stars move together in orderly, almost polite circles, all leaning the same way, all keeping close to the plane. Up here, the orbits widen. They tilt further from the flat and dip and rise as they travel, carrying their stars higher above the plane, and lower below it than any thin disk star would wander. Nothing about this motion is chaotic. It simply traces looser, taller paths, as if these stars had once belonged to a more orderly arrangement and were nudged into something roomier. What actually nudged them is where the story turns honest rather than tidy. Astronomers do not agree, not fully, on how the thick disk came to exist. This is not a settled chapter of galactic history with a single confirmed cause. It is an active question, argued over in papers and conferences, and any account we give here has to be held a little loosely. One leading idea, and it is an idea rather than a proven fact, points to an ancient collision. Sometime in the galaxy's distant past, researchers propose a smaller galaxy fell into the Milky Way and merged with it. Some call this event the Gaia-Enceladus merger, named for the space mission that helped uncover the traces it may have left in the motions of nearby stars. The thinking goes that before this merger, the Milky Way may have already had a thinner, calmer disk of its own, not unlike the one we live in now. Falling through and mixing with that early disk, the incoming galaxy could have stirred its stars upward and outward, puffing a once flat arrangement into the thicker, looser shape we are moving through tonight. It is a compelling picture, and it fits a good deal of what we observe in the ages compositions and orbits of thick disk stars. But compelling is not the same as settled. The exact mass of that ancient incoming galaxy is still debated, with estimates that shift as new data arrives. Precisely when the merger happened is debated as well, with different lines of evidence pointing to somewhat different windows of time deep in the galaxy's youth. Some researchers favor other explanations entirely, including the idea that stars could have been born already puffed up, heated by turbulence in a young, still-forming galaxy, rather than stirred later by an outside visitor. We are not going to pretend this is resolved, only to sit with the layer itself and let the question stay open the way it honestly is. None of this uncertainty comes from a lack of looking. Large surveys have spent years measuring the chemical fingerprints of great numbers of stars scattered through this layer, sorting them by how much of the heavier elements they carry, and by exactly how their orbits tilt and stretch. That patient sorting is what first separated the thick disk from the thin one in the first place. Two overlapping populations that would otherwise blur together into a single band of light. The boundary between them is not a hard line so much as a shifting balance. More old, metal-poor, wide-orbiting stars the higher you climb, more young, metal-rich, close-orbiting stars the lower you sink, with a broad overlapping middle where either kind might be found. Astronomers studying other spiral galaxies, seen edge-on from far outside the way ours never can be, have found the same layered structure again and again. A thin, bright band sits low and crowded, and a fainter, thicker haze of older light stands above and below it, visible in galaxy after galaxy across the sky. That repetition matters. It suggests the thick disk is not some accident unique to our own galaxy's history, but a common outcome of how spiral galaxies grow and settle, whatever the exact cause turns out to be here. Seeing that same soft double structure elsewhere is some of the best evidence that whatever built ours was not an unusual event. However, its precise story is eventually resolved. Even the language used to describe this layer carries a kind of built-in patience. Ages for these stars are usually given as broad, rounded spans, several billion years old at least, rather than as fixed dates anyone could circle on a calendar. That roundedness is not vagueness for its own sake. It reflects how hard it actually is to date a star precisely from this distance, and how honestly most working astronomers would rather leave a wide defensible range than offer a tidy figure that later evidence might quietly overturn. Spectroscopic surveys, built specifically to measure stellar chemistry across wide swaths of the galaxy, peering through dust using infrared light where visible surveys would be blocked, have mapped the thick disk's composition in far more detail than was possible only a generation ago. Combined with precise position and motion measurements from space-based astrometry missions, these surveys let researchers trace not just where thick disk stars sit today, but the shapes of the orbits that carried them there, reconstructing, star by star, the slow choreography of a structure that took shape long before any of the astronomers studying it were born. There is a small, ordinary scene that might help hold this shape in mind. Picture a jar of water left on a windowsill overnight, water carrying a mix of grains stirred into it before bed. By morning, the heaviest and finest of those grains have settled into a sharp, thin band right at the bottom of the jar, a clean line where the water above turns clear. But just above that line, something else is happening. A softer, hazier cloud of lighter particles still hangs suspended, unwilling to settle as quickly. Some of it drifting there for hours longer, some of it perhaps never fully coming to rest. The thin disk beneath us is something like that, crisp bottom layer, gathered close and orderly, while the thick disk is the hazier cloud just above it, caught in a slower, gentler kind of settling that may never quite finish. Floating inside that cloud now, we can look at the individual stars around us and sense their different histories without needing to solve them tonight. Each one is a small, steady light that has likely outlived the disk's flattest, most orderly days, tracing its wide loop through space long after whatever stirred it first happened. None of them seem disturbed by not knowing their own origin story in full. They simply continue, carrying their old light through this looser, roomier layer of the galaxy, indifferent to the debates unfolding far below among the astronomers who study them. We linger here a while, letting the hush of this older population settle around us, the way the narration itself is meant to settle a listener towards sleep. The thin disk's brightness has faded well beneath us now, and the thick disk's scattered, ancient stars stretch out in every direction, patient and unhurried. Nothing about this layer asks to be solved before we can rest in it. It only asks to be noticed, held gently, and allowed to remain a little uncertain. The way most honest pictures of something this old and this vast are bound to stay. Yet the cloud has an edge, even if that edge is hard to mark exactly. A place where the haze thins further and grows sparser still. Above that suspended cloud, further from the plane than even these wide orbiting, ancient stars tend to wander. Something else waits in the dark. And so, drifting upward past the last scattered lights of the thick disk, we find ourselves asking again, more quietly this time, what is out there, above even this? Leave the thick disk behind now and rise past it, and the view changes into something no flat map of a disk could have prepared us for. What waits above is not another layer of the same shape, thinner or fainter, laid over the first. It is something else entirely, a vast, roughly spherical halo of stars, surrounding the whole spinning disk on every side at once, above and below and outward in every direction. Just how far this halo reaches is still being measured, and honestly, astronomers do not agree on a single edge. The best estimates place its outer boundary somewhere between 80,000 and 100,000 light-years from the galaxy's center, and some studies push that boundary farther still, out past 100,000 light-years into a faint thinning frontier where individual stars become almost impossible to count. No one claims a precise wall where the halo simply stops. Instead, there is a slow fading, a gradual thinning of starlight into the dark, and the number changes a little every time a new survey looks harder. For all its size, the halo holds only a small fraction of the galaxy's stars, perhaps one star in every 100, scattered so thinly that entire volumes of space, larger than the disk itself, might contain only a handful of them. The disk, by comparison, is crowded and bright with starlight, while the halo around it is enormous and nearly empty, holding far fewer stars across a far greater span of space. Between one halo star and its nearest neighbor, there can lie hundreds of light-years of open dark, a silence so complete that light itself takes centuries to cross it. The stars that live in this halo do not orbit gently in a flat, shared plane the way the disk stars do. They move instead on long plunging paths that carry them up out of the galaxy's center, out through the thick disk we have just left, further out into the halo's deep reaches, and eventually back down again, swinging through the crowded disk before climbing away once more. Each full loop can take hundreds of millions of years to complete. Some of these orbits are steep and nearly vertical, arsing high above the galactic plane before curving back. Others are looser, wider, carrying their star on a slow, tilted wander that touches the halo's edge and returns. Many of the stars scattered through this halo are among the oldest anyone has learned to find anywhere in the galaxy. They formed before the disk itself had settled into its familiar spinning shape, back when the galaxy was still gathering itself out of smaller pieces, still young and unfinished. Their light left them very early in the galaxy's story, and it has been traveling quietly ever since. A halo star's chemistry often carries the signature of that early time: fewer heavy elements, simpler compositions, a kind of plainness that marks it as a survivor from the galaxy's first chapters, rather than a product of its later, richer generations. It would be easy to imagine the halo as simply empty space, with a few stars drifting through it, an afterthought around the true galaxy. That is not accurate. The halo has its own shape, its own population, its own long history, distinct from the disk in almost every way that matters. It is not a leftover or a boundary marker, but a structure in its own right, built from some of the earliest material the galaxy ever held, one that continues to shape how astronomers understand the galaxy's full, layered architecture. Some of that history is written directly into the halo's shape, if you know how to read it. Long, thin arcs of stars, called stellar streams, thread through parts of the halo like faint seams left behind after older, smaller galaxies wandered too close to our own and were slowly pulled apart by its gravity. One well-studied example traces back to a small satellite galaxy still in the process of being unraveled. Its stars stretched into a long ribbon that wraps around the Milky Way more than once. Finding streams like this took years of careful sky surveys, matching the motions and compositions of many individual stars until a pattern emerged from what had looked, at first glance, like ordinary scattered light. Each stream is essentially a fossil, a slow-motion record of an older galaxy's last stretch of existence as a separate structure, still visible in outline even after being pulled apart. That kind of evidence has turned the halo into something astronomers sometimes call a record of galactic archaeology, a place where the Milky Way's past absorptions and mergers can still be traced, star by star, long after the smaller galaxies involved have lost any separate identity of their own. Some researchers now divide the halo loosely into an inner portion, closer to the disk, and somewhat more settled into orderly motion, and an outer portion, farther out, more scattered, and carrying stronger traces of past mergers in its star's chemistry and orbits. The line between the two is not sharp, and different studies draw it in slightly different places, but the general picture holds: closer in, calmer and older settled; farther out, wilder and more clearly built from absorbed pieces. Certain stars scattered through the halo have earned a particular kind of trust from astronomers trying to measure distance out here. Stars of a specific type brighten and dim on a steady, predictable rhythm, and because that rhythm is tied closely to how much light they actually give off, comparing the rhythm to how bright they appear from Earth lets astronomers work out how far away they sit, one careful reading at a time. Scattered generously through the halo, these stars have effectively become a kind of measuring tape stretched across the whole structure, letting its rough size and shape be pieced together from many individual, patient distance readings, rather than any single instrument capturing the halo all at once. None of this makes the halo feel crowded, even with all its history layered into it. Walk in your mind from one halo star to the next, and the distances involved would swallow whole solar systems without effort. Hundreds of light years of open dark between neighbors that might, chemically, be siblings from the same long-vanished galaxy. That is part of what makes the streams so remarkable to find at all. They are not bright, connected structures, the way a river is, but ghost-thin trails of individually faint stars spread across enormous volumes of space, held together only by the shared fact of where they came from and how they are moving, a pattern invisible to any single glance and legible only once enough patient data has been gathered and laid side by side. A small number of halo stars carry so little of the heavier elements that astronomers regard them as something close to living fossils, chemical relics from very close to the beginning of the galaxy's star-forming history. Stars like the Sunday carry a rich mix of elements, forged and scattered by countless earlier generations of stars that lived and ended long before our own star ever formed. The most extreme halo stars carry almost none of that inherited richness. Chemical compositions closer to the raw material the universe itself started with, before many generations of stellar life had a chance to enrich it further. Finding and studying a star like that is, in a real sense, close to reading a first-hand account of the galaxy's earliest chapters, written not in any language, but in the plain chemistry of starlight itself. The process that built these streams has not stopped. Smaller galaxies and dense star clusters continue to drift near enough to the Milky Way's gravity to be gradually pulled apart, even now adding new material to the halo on timescales, too slow for any single human lifetime to notice happening. In that sense, the halo is less a finished structure than a slow accumulation still underway, gathering new threads the way a riverbed gathers new sediment, one long, patient absorption at a time. What we are drifting through tonight is not a museum piece, settled and complete, but a work still quietly being added to star by star, stream by faint stream. Consider, for a moment, a much smaller and more familiar kind of invisibility. In a still, dim room, dust hangs suspended in the air, present everywhere, touching nothing, moving on currents too slow to feel. No one notices it. Then, in the late afternoon, a single narrow beam of sunlight slips through a gap in the curtains and crosses the room at an angle, and suddenly the same dust that was always there becomes visible, caught and lit within that one shaft of light, drifting in lazy spirals that had been happening, unseen the whole time. The room was never empty. Only the light was missing. The stellar halo is something like that suspended dust. It was always there, wrapped around the disk in every direction, its stars scattered so thin that most of the sky simply looks dark where they sit. Finding it took long exposures, careful surveys, patient sweeps of the sky by instruments built to catch the faintest points of light, revealing how much of the galaxy's true shape had been hiding in that quiet volume all along. Once astronomers found the right instrument, the right shaft of light, the halo appeared where before there had seemed to be nothing but ordinary dark. We have now risen through the crowded thin disk, through the slower thick disk above it, and out into this wide sparse halo of ancient light, a shape far larger than the galaxy most pictures ever show. And yet even here, above the scattered halo stars and their long plunging orbits, something more waits in the dark, older still and harder still to imagine. Above the motes of that suspended light, what is there, rise higher still, and the scattered light of the halo begins to gather itself into something denser, something almost deliberate. Astronomers have found and counted about 150 of these gatherings so far, each one a tight, crowded ball holding hundreds of thousands of stars, bound to each other so closely that from a distance, the whole cluster looks like a single blazing point rather than a crowd. None of them sit within the disk, among the spiral arms, where our own solar system quietly turns. Instead, they hover above it and below it, scattered through the halo in a loose sphere that surrounds the entire galaxy, the way a cloud of slow-moving lights might surround a distant town, visible from every direction and belonging fully to none of them. What makes these clusters remarkable is not only where they are, but when they arrived. But most of them formed somewhere between 12 and 13 billion years ago, in the young universe, long before the Milky Way had settled into the familiar spinning disk we know today. Our own Sunday, by comparison, is only about 4.5 billion years old. Set the two numbers side by side, and the truth becomes almost startling. In its simplicity, the Sunday is the newcomer here. It is the young arrival at a gathering that was already old, already full, already glowing steadily, for billions of years before our star ever condensed out of its own cloud of gas and dust. Every sunrise humanity has ever watched has happened in the presence of light that was already ancient before the Earth existed to receive it. Two of these clusters are worth naming because both can still be found tonight by anyone willing to look. Omega Centauri, the largest known cluster orbiting our galaxy, holds several million stars in a ball wide enough to be seen from Earth with nothing more than a clear sky and patient eyes. Messier 13, sometimes called the Great Cluster in Hercules, is fainter but no less remarkable, a smudge of combined starlight that resolves, through even a modest telescope, into thousands of individual points, each one its own sun, each one its own possible world. Both have been shining, essentially unchanged, since long before there were eyes on Earth to look up and notice them. Now imagine, for a moment, standing on a world that orbits a star inside one of these clusters, rather than out here in the comparatively empty suburbs of the galaxy, where our own solar system sits. The night sky above that world would bear almost no resemblance to ours. Thousands of stars would crowd close enough together that darkness, in the sense we understand it, would never fully arrive. Many of those stars would burn bright enough that reading by their combined light without any lamp or fire would be entirely possible. Twilight there would not fade into black. It would fade into a soft, permanent glow. Dimmer than day but never truly dark. A sky so full that the very concept of a moonless night might not exist for whoever lived beneath it. There is a way to hold this picture that makes it feel closer to something familiar. Picture paper lanterns, strung high over a garden, hung there for a gathering long ago and never taken down. Generations of guests have arrived at that garden since, each new group certain the party belongs to them, each unaware that the very same lanterns, lit by hands none of them ever met, were already glowing overhead before any of them, or their parents' parents ever walked through the gate. The garden changes hands. Its guests change entirely, again and again, decade after decade. But the lanterns keep burning, indifferent to who happens to be standing beneath them on any given night, exactly as they were found by the first guest who ever looked up and wondered who had lit them. That is something close to what these clusters are. They are not part of the party currently gathered in the galaxy's disk. All the young blue stars and the busy star forming regions, and the Sunday itself with its handful of planets. Older than the invitation itself, they were burning before the garden, in a sense, was even built around them. And they will likely go on burning long after everything currently orbiting nearby has changed beyond recognition. To look toward one of them tonight is to look at light management by no living memory, tended by nothing, sustained only by physics that has not needed correcting in longer than is easy to picture. And there is a quiet comfort tucked inside that thought, if one sits with it. These clusters have watched, in a manner of speaking, everything our galaxy has become. They were already ancient when the Sunday was born, and they will likely still be shining, largely unchanged, long after the Sunday has finished the slow arc of its own life. Their permanence is not cold. It does not press down, only sits there above the ordinary plane of the galaxy, patient, dense, with old light, entirely unbothered by how briefly any single visitor gets to look up and notice it. Not every one of these clusters was necessarily born alongside the Milky Way itself. Careful study of their orbits, some circling the galactic center in the same direction as the disk's own spin, others moving the opposite way entirely, has led some astronomers to suspect that a portion of this population may have arrived from outside, captured long ago from smaller galaxies, that wandered too close and were gradually absorbed. A cluster moving against the grain of everything around it is, in a quiet sense, a guest who never quite lost its accent, still tracing the memory of wherever it first began its journey. Density is part of what makes these places so unusual. Inside a typical globular cluster, stars can be crowded closely enough that gravitational encounters between them, close passes and occasional collisions, happen far more often than anywhere in the ordinary disk, where a star like the Sun rarely comes within many light years of a neighbor across an entire lifetime. That crowding has led some astronomers to wonder whether a few of the largest clusters might harbor something unusual at their centers, a concentrated weight of mass unlike the smaller stellar remnants found scattered through ordinary space. The evidence remains debated, watched carefully rather than confirmed. One more open question, resting quietly inside these old, dense gatherings of light. Because they are so old, these clusters have also become one of astronomy's more reliable rulers for the universe's own age. Study the faintest, coolest stars still burning steadily within a cluster like this. Compare their brightness and color against careful models of how stars age, and you arrive at a minimum age for the cluster itself, one that in turn sets a firm floor under the age of the universe as a whole. The universe, whatever its exact age turns out to be, cannot be younger than the oldest lantern still burning quietly within it. Not all 150 are identical in scale, either. Some hold barely tens of thousands of stars, modest by the standards of this population, while the very largest, places like Omega Centauri, may hold millions. Dense enough that some researchers suspect it may once have been the stripped core of a small galaxy in its own right, its outer layers long since pulled away, leaving only this tightly bound heart, still orbiting quietly, where a whole galaxy might once have stood. If that idea holds up, then wandering near Omega Centauri tonight means passing something closer to a survivor than an ordinary cluster, the compressed remnant of a much larger structure that the Milky Way slowly took apart over a very long stretch of its own history. A few of these clusters carry visible evidence of their own slow unraveling. One cluster, fainter and looser than most, trails a pair of thin tidal tails behind it, streams of stars pulled gently away by the galaxy's gravity. Each time the cluster's orbit carries it close to the crowded disk. Watching a cluster lose stars this way, gradually and over an immense stretch of time, is a reminder that even these ancient, tightly bound gatherings are not perfectly permanent. They are simply extremely patient about how slowly they come undone. There is a particular kind of stillness in knowing how old that light actually is. The glow reaching us tonight from Omega Centauri, or from Messier 13, set out on its journey long before anyone alive had ancestors who had learned to write, long before cities, long before most of what any history book bothers to record. It has been crossing open space for all of that time, indifferent to every human milestone that happened while it traveled, arriving now on an ordinary night simply because it finally had the distance behind it to arrive at all. Consider, too, how unhurried this quiet actually is. Hundreds of thousands of stars, packed into a space that would fit comfortably within a small pocket of the galaxy's vast disk, and yet nothing about it feels crowded or chaotic from where we sit. It feels composed, restful even, The way a great many small flames arranged carefully together can feel calmer than a single fire, precisely because none of them needs to burn fiercely to be seen. Each star in Omega Centauri or Messier 13 has simply been allowed to keep burning, gently, for longer than almost anything else in this galaxy has been allowed to do anything at all. Let the eye drift outward from these clusters now, past their crowded light, into the wider dark that holds them. They are not the outermost thing here, merely the last visible thing, the last cluster of solid, countable light before the halo gives way to something far more diffuse, something too faint and too vast for any single point of light to represent. The clusters themselves seem to float in that emptiness, the way lanterns float above a garden that has long since gone quiet for the night, marking a boundary without quite explaining what lies past it. So the question rises again, gently, the way it has risen at the close of every layer so far. Above the lanterns, past the last of that old and patient light, what is there? Past the lanterns now, past every last globular cluster hanging in its slow orbit, the galaxy does not simply stop, it thins. What surrounds it out there, for hundreds of thousands of light years in every direction, is not empty space at all. It is a breath. A vast, quiet envelope of gas wraps the entire disk. The spiral arms, the bulge, the lanterns and everything else we have passed on this journey, holding it all inside something far larger than itself. This envelope has a name astronomers use quietly among themselves, the circumgalactic medium. Set the name aside. Think of it simply as the air the galaxy breathes. If a galaxy could be said to breathe at all. It extends so far beyond the visible disk that if you could see it glow, the Milky Way would look less like a spiral and more like a soft rounded cloud, with the bright disk we know as only the smallest, densest heart of something enormously larger. And this breath is hot, astonishingly hot. Temperatures within it climb to roughly 1,000,000 degrees. Hot enough that if you tried to imagine it as fire, the comparison would already fail you. Nothing burns out there. There is no flame, no glow you could see with your eyes. Because heat in this context does not mean what it means in a kitchen or a hearth. It means the particles are moving with tremendous speed, colliding rarely, carrying enormous energy in a space so open that almost nothing is there to receive it. That is the quiet contradiction at the center of this chapter. The gas is ferociously hot, and yet it could not warm your hand, because there is almost nothing of it to touch you. Take a single cubic meter from anywhere within this halo, and you would find fewer particles inside it than exist in the finest vacuum ever built by human hands in a laboratory on Earth. Engineers spend years and vast sums chasing emptier and emptier chambers, pumping out every last molecule they can, and still the vacuum they achieve is more crowded than the space that wraps our entire galaxy. Here, nature has already outdone them, effortlessly, across a volume too large to picture. So little is present in any one place that for decades this halo went almost entirely unnoticed. It carries no light of its own worth speaking of, nothing bright enough to register in an ordinary telescope pointed outward. And yet current estimates, still being refined and debated as better instruments come online, suggest this thin, invisible envelope may hold as much ordinary matter as all of the galaxy's stars combined. Every sun we have named in this journey, every lantern cluster, every faint dwarf companion drifting nearby, Its total mass in stars may be matched, or perhaps even outweighed, by gas so sparse it would register as nothing at all in the palm of your hand. That figure is not settled fact. It shifts as surveys improve, as models are tested against new light. But even as an estimate, it reshapes what we mean when we say we have seen the galaxy. The visible stars, it turns out, may be only half the story, wrapped in an ocean of gas too faint to see directly. If it cannot be seen glowing, how was it ever found? Astronomers noticed it the way you might notice a pane of glass you did not know was there, not because the glass shines, but because it bends and dims the light passing through it. Distant quasars, some of the brightest objects in the universe, send their light across billions of years to reach us. On the way, some of that light passes directly through this halo surrounding our galaxy, or through similar halos surrounding others. The gas absorbs a narrow, telltale sliver of that light, a shadow cast not by blocking it outright, but by quietly filtering certain wavelengths as it passes through. Read that faint absorption pattern carefully enough, and the presence of the gas becomes undeniable, even though no telescope has ever captured it, shining on its own. Detecting gas this hot, in practice, usually means looking in the higher energy light called X-rays, rather than ordinary visible light. Since gas at these extreme temperatures gives off most of its faint glow at wavelengths no human eye could ever perceive directly. Space telescopes built specifically to catch that kind of light have captured soft, diffuse glows around the Milky Way and around similar galaxies nearby, confirming through direct emission what the quasar shadow method had already suggested indirectly. Two very different techniques, one reading an absence and one reading a faint glow, arriving at the same quiet conclusion about how much is really out here. Picture for a moment something far smaller and far warmer than a galaxy, a single loaf of bread, fresh from an oven, sitting on a counter in an otherwise ordinary kitchen. Within minutes, its smell has reached the front hallway. It has drifted up the stairs, settled into the corners of a room where no one is baking anything at all, touched every doorway in the house. Stand anywhere under that roof, and you know, without being told, that somewhere nearby, bread was made. And yet, if you tried to reach out and gather that smell, to hold it in your hands the way you might hold the loaf itself, you would find there is almost nothing there to hold. It fills the whole house while remaining, in any single place, almost nothing at all. That is close to what this halo is. A presence that reaches everywhere around the galaxy, felt in its effect on light passing through, made of almost nothing when measured in any one small place. This halo is not simply a passive shroud sitting around the galaxy, unchanging. It appears to be connected, in slow and important ways, to how the galaxy continues to grow. Models suggest that some of this hot, thin gas gradually cools as it drifts, sinking inward over enormous stretches of time, eventually joining the cooler, denser gas of the disk itself, where it can go on to form new stars. Astronomers sometimes describe this slow exchange as a kind of galactic fountain, gas lifted outward by the churn of stars forming and stars reaching their own quiet end near the disk, then gradually raining back down from the halo over spans of time too long for any single instrument to watch start to finish. If that picture holds, the vast quiet envelope surrounding us tonight is not simply a boundary. It may be part of the very fuel supply, The disk has been quietly drawing on for the whole of its long history. This gas also helps answer a puzzle astronomers sometimes call the case of the missing ordinary matter. Careful accounting of the universe's total ordinary matter, built from measurements of the early universe long before any star had formed, predicts more of it than telescopes could ever find gathered into stars and galaxies alone. For years, a meaningful share of that predicted matter seemed to be simply missing, unaccounted for anywhere astronomers could point a telescope. Halos like this one, quiet and nearly invisible around every galaxy, are now understood to hold a significant part of that answer. Vast reservoirs of thin, hot gas too faint to show up in ordinary surveys, hiding the missing material in plain, transparent sight. Every large galaxy nearby seems to carry an envelope, like this one, wrapped loosely around it, the way our own is wrapped around us. Some astronomers picture neighboring galaxies as living inside overlapping breaths, their individual halos extending far enough that two galaxies separated by an enormous gulf of ordinary space might, in this thin and rarefied sense, already be brushing against one another's outer gas long before their visible disks ever draw close. Nothing about that overlap is felt or seen directly. It is inferred the same patient way the halo itself was found, through careful absorption studies of light passing through vast, mostly empty space on its way to us. But it means the boundary between one galaxy's territory and another's is far softer and far less exact than any simple picture of separate, isolated islands of light would suggest. Consider what this means for the shape of what we have been calling all this journey simply the galaxy. The lanterns we passed a moment ago seemed ancient and outermost, ringed in emptiness. They are not outermost at all, orbiting within this greater breadth, small and bright, within something colder, thinner, and vastly larger than themselves. Every star we have named, every cluster we have paused beside, sits inside this halo, the way a house sits inside the smell of its own kitchen, embedded in something that extends so far past its walls that the walls themselves start to seem like only a beginning. We have now risen past the disk, past the lanterns, past even this improbable, breathing gas that some estimates say may outweigh every star combined. Anyone tracing our galaxy's true edge would need to keep going, further than the eye or even the finest telescope can follow directly. Something else waits out there past the gas, unseen not because it is too faint to glow, but because it may not glow at all. Holding the whole galaxy, stars, lanterns and breath together in a grip we can measure only by its pull, and above that vast, invisible breath, further still, what is there? The stars out past the visible edge of our galaxy keep a pace that the visible galaxy alone cannot explain. Their orbits carry them around the center, faster than the pull of the stars, the gas, and the dust we can actually see would allow. Something more must be holding them to that speed. Astronomers describe it as a vast halo of matter that does not shine, does not glow, and does not block starlight the way ordinary matter does. It surrounds the whole visible galaxy, reaching well beyond the last stars we can count, though its outer edge is not a single fixed line. Estimates place its radius anywhere from roughly 100,000 light-years to several times that, depending on which model of the galaxy's motion an astronomer uses. No one states it as one number because no one has measured an edge directly. What they have measured is motion, and motion is enough to build a case. Picture For a moment, a tent raised at night, you see the canvas catch what little light there is, and its shape settles into something you can trace with your eyes. A peak, a slope, a taut line running down to the ground. But the fabric alone does not explain why it holds that exact shape against the air moving around it. Somewhere beyond the canvas, out past what your eyes take in directly, guy ropes are staked and pulled tight, holding the tent's form from points you never see but can work out from how the canvas behaves. The galaxy's visible disk is the canvas, and the halo is inferred the same way, not seen directly, but read from how the visible part holds its shape and keeps its pace. This is, in the end, an old and familiar kind of reasoning, dressed in a new scale. We do not see wind, only leaves turning, branches bending, a curtain lifting from an open window, and from that motion we know something is moving through the air, even without a direct look at it. Astronomers watching the outer stars are doing much the same thing, reading motion and drawing a conclusion about what must be present to produce it. They call this unseen mass dark matter, and while its exact nature is still being worked out in laboratories and observatories around the world, its gravitational fingerprint on the galaxy's rotation is about as well established as anything in modern astronomy. This puzzle is not new. Decades ago, careful measurements of how fast stars circle at different distances from a galaxy's center began turning up a persistent oddity. In a galaxy made only of the matter astronomers could actually see, stars far out toward the edge should orbit more slowly than stars closer to the crowded center, the same way planets farther from the sunday move more slowly than planets close in. That is not what the measurements showed. Instead, the outer stars kept pace with the inner ones, far more closely than visible matter alone could explain. A flat, rather than falling curve of speed against distance. Researchers who first noticed and pressed on this discrepancy, checking it against galaxy after galaxy, rather than dismissing it as a fluke, helped turn a persistent anomaly into one of the most consistently reproduced results in all of astronomy. Since then, other lines of evidence have arrived independently, and each has pointed toward the same unseen mass rather than away from it. Light from distant galaxies, passing near a foreground cluster on its way to us, bends slightly, warped by the gravity of everything sitting in that cluster's path, seen and unseen alike. Measuring exactly how much that light bends lets astronomers map where mass actually sits. And again that mapped mass extends far beyond where visible starlight alone would place it. Different method, different galaxies, same conclusion. That kind of agreement across unrelated techniques is part of why so few working astronomers doubt that something substantial and unseen is out here, even while its precise identity remains unknown. What this unseen mass actually consists of remains one of physics' more stubborn open questions. It is not made of the ordinary atoms that build stars, planets, and everything else familiar, since it neither absorbs nor emits light the way ordinary matter does under any condition tested so far. Researchers have proposed various kinds of undiscovered particles that might account for it, built detectors deep underground shielded from ordinary interference, and waited patiently for a signal that has not yet arrived in any confirmed form. But absence of a direct detection is not itself evidence against the idea. It simply means the search continues, methodical and unhurried, in laboratories that will likely still be running long after. Tonight's narration has ended, chasing a particle whose gravity we can already read clearly, even while its true nature stays hidden. One more measurement belongs here, briefly before we move on. 2 space observatories, one named Fermi and one named eROSITA, have each detected enormous lobes of hot gas rising above and below the very center of our galaxy. Those lobes are enormous by any ordinary measure, rising far above and below the crowded galactic center, faintly glowing in gamma rays and in the softer, higher energy light called X-rays, rather than in anything visible to an unaided eye. Their edges are surprisingly sharp for something so vast, a crisp boundary rather than a slow fade, which is part of what makes them so puzzling. A relatively brief burst of energy from the galactic center seems the likelier explanation to many researchers, whether from an old episode of feeding at the very center or from an intense, short-lived surge of star formation there. But distinguishing between those possibilities from this distance remains genuinely difficult, and whether those lobes trace back to past activity at the galactic core or to an old concentrated burst of star formation, there remains genuinely unresolved among the astronomers who study them. A question for another night's journey into the galaxy's center rather than this one. For now, what we can hold on to is simpler and calmer than it might first sound. The galaxy we can see, its stars, its gas, its long spiraling arms, sits inside a far larger structure that we know mainly by its effect on motion. The way a held shape tells you something is pulling from beyond your sight, without needing to name exactly what waits at each stake in the ground. It is a quiet kind of evidence, patient and mathematical, gathered orbit by orbit rather than glimpsed all at once. And above that shape, holding the galaxy the way unseen ropes hold a tent against the night air, what companions travel with us through the dark, close enough to watch, far enough to be their own small worlds of stars. Ahead through empty light, the highway of gas and stars we have been climbing gives way at last to open dark. Below and slightly behind now, the disk holds its long companions, points of light too faint for names, and among them 2 stand apart, if only we knew where to look. Southern skies on Earth carry a pair of soft smudges that no telescope is needed to find. The Large Magellanic Cloud sits some 160,000 light-years away, and its smaller companion, fittingly called the Small Magellanic Cloud, drifts a little further, near 200,000 light-years out. To the unaided eye, they look like torn scraps of the Milky Way's own faint glow, wisps that seem to have drifted loose from the great river of stars overhead. Sailors who steered by them centuries ago read them exactly that way, as detached clouds, some stray weather of the galaxy, harmless and familiar. Only later would it become clear that these were never pieces of home at all. Each is a galaxy in its own right, entire and independent, holding its own billions of stars, its own slow spin, its own long history that began nowhere near us. Around these 2 brighter clouds, if the eye could be sharpened past what any telescope on Earth allows, a scattering of far fainter companions would come into view. Dozens of dwarf galaxies keep loose company with the Milky Way, so dim that most were only found in the last few decades, hiding in surveys as thin smudges of ancient, slow burning stars. They carry no light show, no spiral arms, no glow bright enough to draw a name from a sailor's eye, simply persisting small and quiet, held in orbit by the same gravity that shapes everything larger nearby, Finding those faintest companions took a very particular kind of patience. Wide sky surveys, scanning enormous stretches of the heavens and recording the position and brightness of every point of light within reach, gradually built up catalogues so large that computers, rather than human eyes, became necessary to sift through them for anything unusual. Buried inside that flood of ordinary stars, astronomers began finding faint, loose overdensities, patches where slightly too many old, dim stars clustered together to be random chance. Confirmed one by one, these overdensities turned out to be dwarf galaxies, so faint and so diffuse that earlier generations of astronomers, working with less sensitive instruments and smaller surveys, had simply looked straight through them without ever suspecting they were there. Some of the faintest confirmed companions hold only a few thousand stars total, dim enough that an entire small galaxy of this kind can be outshone individually by a single bright star in our own sky. The largest of the Milky Way's companions, meanwhile, is doing more than simply drifting nearby. Detailed measurements of its motion suggest it may be on its first close approach to our galaxy, having fallen in from farther out relatively recently on cosmic timescales, rather than having settled into a long, stable orbit the way older theories once assumed. Trailing behind it and its smaller partner stretches a long ribbon of stripped gas, pulled loose by the tidal tug of the encounter and stretched across a vast arc of sky, a faint gaseous wake left by two galaxies, gradually being pulled apart from each other, even as they are pulled closer to us. Despite being a fraction of the Milky Way's size, the larger of the two bright clouds is far from a quiet place. Deep within it sits one of the most vigorous stellar nurseries known anywhere nearby, a sprawling region of glowing gas where new stars are forming in unusually large numbers, among them some of the most massive and luminous stars ever catalogued. Astronomers studying that region have found stars burning so brightly and so briefly that they stand near the upper limit of what current theories say a star can weigh and still hold together. Seen from Earth, the whole glowing structure is faint and diffused to the unaided eye, one more soft thread in that torn scrap of light low in the southern sky, giving no obvious hint of the furious stellar activity actually unfolding within it. There is a particular quiet irony in how these two bright clouds first entered written history. Sailors on a long ocean voyage centuries ago, navigating waters unfamiliar to their home ports, used the two patches as steady markers low on the southern horizon. Features reliable enough to help mark a ship's position through long nights at sea, long before anyone understood what those pale smudges actually were. The expedition's own name eventually attached itself to the clouds, an accident of history rather than any deliberate christening, and the label has simply stayed ever since, carried forward through centuries of astronomy into tonight's own telling of it. What began as a practical tool for finding one's way across an ocean became, centuries later, two of the nearest known galaxies beyond our own, named for the voyage that once used them only to keep from getting lost. None of these companions are guaranteed to stay companions forever. Models of their orbits suggest the larger bright cloud is moving on a path that may eventually carry it into a slow merger with the Milky Way itself, an event still likely billions of years away, folded into a future stretch of time so distant that the Sunday's own story will have changed considerably before it happens. Smaller companions have already met that fate more than once in the galaxy's past. One dwarf galaxy, discovered only in the last few decades, hiding almost directly behind the crowded bulge at our galaxy's center, is currently being pulled apart by the Milky Way's gravity. Even as we drift here tonight, its stars gradually stripped away and folded into our own halo, joining the very streams we passed a few chapters back. Company out here is rarely a fixed arrangement. It is closer to a long, slow procession, some companions newly arrived, some mid-collision, some already fully absorbed and indistinguishable from the halo that swallowed them, all moving on a timescale far too patient for any watching eye to see change from one night to the next. This modest fleet, bright pair and dim scatter together, marks something worth pausing on. Everything visited so far on this climb, the disk, the bulge at its heart, the globular clusters ringing above and below, the dark unlit halo that wraps around all of it, has belonged to one single galaxy. It is only here, among the Magellanic Clouds and their fainter kin, that the journey crosses a real boundary for the first time. These are the nearest things in the universe that are not us. Not part of the Milky Way, not bound into its disk or its halo, as one structure, but separate galaxies, whole and complete, that simply happen to lie close enough to be swept along in our company. A useful way to hold this in mind, and only this once, is to picture a large ship at anchor for the night, and a handful of small boats moored along its side. Glanced at from the deck in poor light, they might seem like part of the ship itself, tucked so close against the hull that the eye reads them as one vessel. But every one of those small boats has its own hull, its own crew, its own voyage that brought it to this stretch of water. They are not pieces of the ship, simply drawn in by the same currents that hold the ship in place. Resting near it for now, free to drift on if those currents ever changed. The Magellanic Clouds and their dim companions keep exactly that kind of company with the Milky Way. Close, familiar, easy to mistake for part of the whole, but never actually part of it. Newer, wider surveys continue to add faint companions to this list. Even now, each discovery pushing the known total higher and hinting that still more remain to be found, hiding at the very edge of what current instruments can detect. Other large spiral galaxies nearby seem to host satellite systems of a broadly similar kind, their own scatter of bright and faint companions drifting nearby, suggesting that this whole arrangement, one substantial galaxy attended by a loose court of smaller ones, is closer to a common pattern across the universe than any unique feature of our own particular corner of it. Knowing this changes how the darkness around us reads. What looked, a chapter ago, like empty space beyond the galaxy's tent of dark matter turns out to hold neighbors of its own, small craft riding the same gravitational tide that carries our galaxy through its long night. They will not merge with us for a very long time, if ever at all, and for now they simply keep station nearby, close enough to see, far enough to remain unmistakably their own, somewhere far beyond even these companions, past the reach of any boat moored this close, larger structures wait. Whole other galaxies, whole clusters of them, gather at distances the mind can only approach slowly, one step at a time. But that is a horizon for later. For now, let the boat settle back into the dark behind us, small and patient, and let the climb continue upward, past the last of the company we can name. and above the boats, past even their faint and scattered kin. What opens out there, straight above the disk, where the last thin scatter of our galaxy's stars finally gives out, lies a small and quiet patch of sky called Coma Berenices. It is not a bright constellation. Nobody points a garden telescope at it on a whim, and no bold myth clings to its stars, the way one clings to the hunter or the bear. It sits faint and sparse, almost apologetic, the kind of sky most people's eyes straight across on their way to something more obviously beautiful. And yet this modest little patch holds the North Galactic Pole, the exact point directly above the disk of the Milky Way, the one direction in the northern sky where our galaxy's dust and stars thin out to almost nothing between us and everything beyond. Below the disk, the mirror point does the same work. The South Galactic Pole sits inside Sculptor, another constellation that asks for nothing and gets little. Sculptor was named for a workshop, a modeler's studio, and there is something fitting in that. It is a plain room that happens to hold a doorway. Both of these constellations were assigned their borders by astronomers doing careful, unglamorous cataloguing work, centuries before anyone understood what those particular coordinates meant for seeing outward. Neither one was chosen for its poles. The poles simply happened to fall there, the way a keyhole simply happens to be wherever the door was built. What makes these 2 points different from every other direction in the sky is not brightness. It is clarity. Look toward the bright band of the Milky Way itself, and the view out to the deeper universe is blocked, layer after layer, by our own galaxy's disk, countless stars, and threaded among them, vast drifting clouds of gas and dust that swallow and scatter light before it ever reaches us. That obscuring material is concentrated in the disk, the way smoke gathers along a ceiling. Above and below that disk, along the axis running through the 2 poles, almost none of it remains. Looking toward Coma Berenices or toward Sculptor, we are looking through the thinnest possible slice of our own galaxy out into the open dark, beyond it. Picture a window in winter, fogged over by the warm breath and gathering damp of a room, so that the glass has gone soft and pale, and every shape beyond it is smeared into vague light. Someone once wiped a small circle, clear near the very top of that window, higher than eye level, usually reaches, and it has stayed clear ever since. Everyone in the room keeps drifting back to the smeared glass at eye level, because it is close and familiar and easy to reach without looking up, even though the view there is clouded and uncertain. The one truly clear pane has been sitting above them the whole time, small, unremarkable, almost forgotten, and open all the way through to whatever lies outside. That is what Coma Berenices and Sculptor are for us. 2 clear panes, one wiped near the top of the sky, one near the bottom, both easy to miss precisely because nothing about their appearance announces what they are. A person could spend an entire lifetime under the stars and never once suspect that these 2 faint, sparse patches were the plainest exits our galaxy offers, the 2 directions where its own light and dust step aside and let the deeper dark come through unobstructed. Astronomers rely on these 2 points for more than poetry. The entire galactic coordinate system, the grid used to describe any position in the sky relative to the disk, rather than relative to Earth's own tilted axis, is built with these 2 poles as its fixed anchors, the same way an ordinary globe is built around North and South Pole of its own. Every survey that maps the sky in galactic terms, every chart that describes a star or a distant galaxy by how far it sits from the plane, rather than by ordinary sky coordinates, is quietly using these two unremarkable patches as its reference frame. Whether or not anyone consulting that chart ever thinks to look up and locate them directly, that clarity has made the region around the poles a favorite hunting ground for astronomers studying what lies far beyond our own galaxy entirely. Looking toward the North Galactic Pole, surveys have found rich gatherings of distant galaxies bound together by their own gravity. Vast clusters holding great numbers of member galaxies apiece, visible with unusual clarity precisely because so little of our own galaxy's dust and light stands in the way. Toward the crowded plane instead, similar clusters exist in just as great a number, but many remain effectively hidden, their light absorbed or scattered by the very disk we call home before it can ever reach a telescope on Earth. The poles, quietly, have become two of the clearest doorways astronomers have for studying the wider universe, precisely because our own galaxy gets so completely out of the way there. Quite separately, the disk's tilt relative to the rest of the sky is itself a kind of accident, unrelated to anything else nearby. The plane in which Earth circles the Sunday sits at a steep slant to the galaxy's own disk, tipped at an angle with no particular significance, beyond the simple, unplanned geometry of how our solar system happened to form within the wider structure. That mismatch is, in its own way, a small stroke of good fortune. It means the two galactic poles do not sit hidden behind the Sunday's glare or buried near the horizon for observers on Earth, but instead stand usefully placed in the sky for at least part of the year from most latitudes, open and reachable rather than perpetually out of reach. Careful maps of dust across the whole sky, built up over years from surveys, measuring exactly how much starlight is dimmed and reddened in every direction, confirm the same pattern in fine detail. Dust thickens dramatically toward the crowded plane and thins to almost nothing near the poles, a gradient so consistent that astronomers now use those very dust maps as a standard correction, a way of accounting for how much any given patch of sky has been dimmed by our own galaxy's material before its light is allowed to speak for itself. None of this makes the poles dramatic to look at with an ordinary eye. Held up against the bright, crowded sweep of the Milky Way, arching overhead on a clear night, Coma Berenices and Sculptor will always look thin by comparison, a handful of faint stars, scattered without any obvious pattern worth naming. That plainness is in the end close to the entire point of this chapter. The most useful window in a house is rarely the one with the grandest view. It is simply the one that happens to be clear, and these two quiet patches of sky, unassuming and easy to overlook, have quietly done more to help astronomers see past our own galaxy than almost anywhere else they could have pointed a telescope. There is a quiet humility in that arrangement. The universe does not mark its clearest windows with brilliance. It does not hang a bright star at each pole, the way a lighthouse marks a harbor. Only leaves the material away from those 2 points, thinly and without ceremony, and waits to see whether anyone looks up rather than ahead. For most of human history, nobody had a reason to. The poles were catalogued as coordinates on a chart, useful for orienting maps of the sky, long before anyone building a telescope thought to point it straight through them and simply wait. So, the two windows have stood open, for as long as the galaxy has held its current shape, patient and unlit, asking nothing of the sky around them. They do not compete with the bright band of the Milky Way for attention, and they never will. Their whole value lies in what they are not crowded, not clouded, not veiled in our own galaxy's haze. And still, they wait there now, this very night, directly above and directly below wherever we happen to be standing, through that one small clear pane, wiped high above the fog, what is actually there. The two windows we have just looked through were never meant to show us anything. Astronomers pointed a telescope called Hubble, and later a newer one called James Webb, toward those same clear patches above and below the galaxy's disk. And they chose the patches on purpose, because they looked like nothing. No stars to speak of, and no visible structure. Just a small square of black, tucked into the calmest, emptiest corner of the sky the galaxy's disk would allow. Then they did something that sounds almost too patient to be science. They held the telescope still, aimed it at that one small square, and left it there, not for a moment, not for an exposure of a few seconds, the way a camera usually works, but for days. The mirror stayed open to that patch of sky, gathering whatever light happened to be arriving, one faint photon at a time, and letting it build up hour after hour until something below the threshold of seeing finally became visible. What came back was not emptiness, it was the opposite of emptiness. Filling that small, deliberately boring square were thousands upon thousands of galaxies, each one a galaxy in its own right, each one holding its own billions of stars, layered back through the dark in every direction the image could hold, and the square itself was tiny. Astronomers would later describe its size this way: hold a single grain of sand out at arm's length, and that grain could cover the whole patch of sky the telescope had stared into, an entire field of galaxies hiding behind a grain of sand. The original patch chosen for that very first attempt sat in the constellation Ursa Major, an otherwise unremarkable corner of an otherwise familiar northern grouping, selected largely because nothing bright enough to matter seemed to be there. Later attempts wandered to other quiet corners of the sky, each one just as carefully chosen for its apparent dullness, and each one just as thoroughly proven wrong once the exposure finally finished building. It helps to picture it more plainly. Imagine looking through a keyhole into a room you had always assumed was bare, maybe a storage room you had glanced into once and dismissed, empty walls, nothing there. Now imagine your eye slowly adjusting to the dark on the other side, and as it adjusts, shapes begin to resolve at the very back of the room, and then more shapes behind those, and more behind those, until you realize the room is not bare at all. It is standing full, crowded from front to back, with figures who were there the whole time, simply too far back, and the room too dark for the first glance to catch them. That is what the telescope found when it finally adjusted to the dark above the galaxy's disk. Not a bare room, a full one. So the blankness we call empty space was never truly empty. It only looked that way because of distance, and because of how much distance was actually involved. Light from those far galaxies had been traveling toward us for so long, across a gap so wide that by the time it arrived faint beyond recognition, a whisper too quiet for a glance to register as anything at all. It took days of patient looking, all pointed at one small square, together that whisper up into something a human eye could finally understand as a galaxy, and then as another, and then as thousands more. The decision to attempt this in the first place was not universally welcomed at the time. Telescope time on an instrument like this is scarce and expensive, requested by hundreds of researchers with specific targets already in mind. And spending many consecutive days staring at a patch of sky chosen specifically for its apparent emptiness struck some colleagues as a genuine risk, a gamble that might return nothing more than confirmation of exactly what it seemed to be. The director who approved the attempt used a portion of personal discretionary time to make it happen anyway, betting that patient exposure would beat expectation. When the images finally came back, crowded from edge to edge with galaxies, where careful telescopes had shown nothing before, the gamble was widely regarded as one of the most valuable single observations the instrument ever made. Later missions pushed the same idea even further. A newer space telescope, tuned to catch infrared light rather than the visible light its predecessor specialized in, was pointed at similarly quiet patches and held there again, this time catching light that had stretched and reddened on its long journey toward us, a signature of just how far it had traveled and how long ago it had left its source. Because light takes time to cross space, looking that far out is also, in a very real sense, looking back in time, catching galaxies not as they appear today, but as they looked when the universe itself was only a fraction of its current age. Each new deep field has managed to look a little further back than the one before it, closer and closer to the universe's own earliest chapters. Counting the galaxies found in one small patch and then multiplying that count across the whole of the sky is how astronomers arrive at their best current estimate for how many galaxies the observable universe actually holds. The figure that results is almost too large to hold in mind all at once. Hundreds of billions at the least, by some more generous countings, possibly several times that scattered across a volume of space, too vast for any single number to feel entirely real. And this counting only reaches as far as light has had time to travel since the universe began. Whatever exists beyond that reach, if anything does, sits forever out of view, not because it does not exist, but because its light, however old already, has simply not had time to arrive yet. It is worth sitting for a moment with how ordinary the chosen patches of sky actually were before anyone looked closely. They were not selected because something interesting had already been spotted there, but for precisely the opposite reason. Chosen because nothing at all seemed to be happening. Because a boring, empty-looking corner of the sky was exactly what the experiment required. That detail matters. It means every other equally boring, equally empty-looking patch of sky, in every direction, anyone has never bothered to stare at for days on end, is very likely hiding the same crowded field of ancient galaxies, simply waiting for someone, someday, to hold a telescope still long enough to notice. Multiply that thought across the entire sky, every direction a person could possibly look up and see on a clear night, and the scale becomes almost impossible to hold steadily in mind. It is easier, most nights, not to try, and enough simply to know that the dark overhead, wherever you happen to be lying beneath it, is this kind of dark, not an absence, a depth patiently waiting on someone's willingness to keep looking. None of the thousands of galaxies caught in those small patches were placed there for us to find. They existed quietly for the whole of the time their light spent traveling, indifferent to whether any eye on a small blue planet ever built an instrument patient enough to catch them. Their discovery changed nothing about them. It only changed what we on this end of a very long journey of light finally understood the sky above us to actually contain. There is something quietly moving in that. We spend so much of our lives learning to trust a glance, a first impression, the fast read of a room or a sky. And here, in the coldest and most convincing possible fashion, the universe suggests otherwise. The places that seem most empty may only be the places we have not yet looked at long enough. Absence out here is rarely a fact. Far more often, it is simply a limit, a boundary drawn by how long we were willing to watch and how far our patience was willing to reach into the dark. Picture that crowded little square again, drifting somewhere above the galaxy's northern window. Thousands of galaxies stacked behind a patch of sky, no larger than a grain of sand held at arm's length. Each one of those distant galaxies is itself a version of the very room we started in, filled with its own hundreds of billions of stars, its own quiet spiral arms, its own small worlds turning somewhere in its folds. The deep field was not a single discovery. It was a lesson in how to look, offered once, and then offered again every time a telescope holds still long enough to let the dark answer back. And yet, even a crowd like that has an edge to it. Even the fullest room, once you have counted every figure standing in its shadows, eventually gives way to a wall. So the question worth carrying forward gently is this: beyond that great crowd of distant galaxies, once you have passed the very last of them standing quietly at the back of the room, what is left standing there in the dark beyond? The last house on a long country road where the streetlights simply stop, and the quiet that follows is not a wall, not a boundary, only more of the same dark going on, softly and on and on. We keep rising. Past the crowd of galaxies that filled the deep field a moment ago, past the scattered light of those thousands of faint smudges, and the crowd begins, gradually, to thin. Nothing marks the change. There is no line to cross, no gate, no threshold with a name carved over it. The galaxies simply grow fewer between one stretch of dark and the next, the way trees thin at the edge of a forest, long before you could say exactly where the forest ended. Out here, astronomers give this thinning a name anyway. They call it the local void, a vast, sparsely populated region of space that begins, roughly somewhere beyond the rich clustering we call our cosmic neighborhood. Its scale sits on the order of hundreds of millions of light-years across, though even that number deserves to be held loosely. Voids like this one are not carved out with any precision. Their edges fade rather than end, drawn not by walls of galaxies, but by the slow, uneven falling away of everything we might otherwise count. It helps to picture it less as an object and more as an absence, a place defined by what it does not have. Most of the universe's galaxies gather into filaments and clusters, threads and knots of light strung across the dark like a loose net. A void is what lies in the gaps of that net, not empty in the strictest sense, nor a place where nothing at all exists, but a place where whatever does exist sits so far apart, so sparsely scattered, that from any one galaxy inside it, the sky might show almost nothing moving, almost nothing near. We are fortunate, in a way, to sit only near the edge of this one. Not deep inside it, not stranded in its farthest hollow, but close enough to its border to have felt the last pull of the crowd behind us, and close enough to its interior to sense, ahead, how much room there still is to cross. If our galaxy sat further in, the night sky itself would look different. Fewer neighbors. Sparser, too. The bright smudges scattered among the deep fields, countless faint ones. A softer, lonelier kind of dark. And this, quietly, is where our long climb begins to change shape. We have moved, chapter by chapter, up through cloud and star and galaxy, and cluster, each layer opening onto something larger. But the local void does not open onto a further layer we can name tonight. It is less a threshold than a settling. Astronomers know these voids continue, that space keeps extending beyond this one's soft far edge into further structure, further filament, further cluster, on scales larger still. But we do not need to chase that thread any further right now. It can wait, unnamed, for another night. What matters here in this stretch of the region we can speak of honestly is simply the scale of the quiet itself. Hundreds of millions of light years, roughly, of space where galaxies are rare enough that light can travel a very long way before it meets another shore. Not a void in the sense of nothing, a void in the sense of room. Enormous, patient room, the kind that takes light millions of years just to begin crossing, let alone finish. Consider, for a moment, how fitting it is to call this a void at all. There is still structure here, still occasional galaxies drifting in the distance, still points of light doing what points of light do everywhere, burning quietly in the dark. But the crowd is gone. The busy, layered fullness of everything we pass through to get here. The star fields and the nebulae and the packed spiral arms and the clusters of galaxies bound together by their own gravity. All of that thins into something closer to stillness. A long, unhurried stretch of almost nothing, holding what little there is very far apart. Voids like this one are not rare exceptions, scattered lightly across an otherwise, even universe. They turn out to be the rule rather than the exception. Once the full three-dimensional map of galaxies is laid out and studied as a whole, galaxies gather along thin filaments and broad sheets, tracing a vast, loosely connected lattice that some researchers call the cosmic web, and the spaces between those filaments and sheets, spaces like the one we are drifting through now, actually make up the greater share of the universe's total volume. Seen at this largest of all honest scales, ours is a universe built mostly of room, threaded here and there with a comparatively thin structure that happens to hold all the galaxies anyone has ever counted. Some voids dwarf even this one. Astronomers have mapped regions of the sky where the emptiness stretches wider still. One especially large example spanning a scale that made it, for a time, the largest such region ever confirmed, its interior so sparse that a traveler placed at its center might see remarkably few galaxies in any direction for what would amount to an extraordinarily long journey. Set beside a region like that, our own local void reads as comparatively modest, a smaller, nearer pocket of the same general pattern repeating itself. Quietly, at every scale, the universe seems willing to offer. There is a temptation to think of a void as a kind of failure, a place the universe simply forgot to fill in properly. That framing does not really hold up. A void is not empty by mistake. It is empty because gravity, over unfathomable stretches of time, gathered matter preferentially into the filaments and clusters nearby, drawing material out of these open regions, the way a fire draws air toward itself from every surrounding direction, leaving the space it emptied a little calmer rather than a little poorer. What looks, from inside, like an absence, is really only the far side of a gathering happening somewhere else. Matter redistributed rather than lost. Order emerging elsewhere at the direct expense of density here. Sitting this close to the edge of such a region carries its own quiet consequence for how the sky itself must eventually change, though on a time scale no observer alive tonight could ever witness directly. As the universe continues to expand, the galaxies scattered around the crowded side of our position will drift very slowly, farther from each other, while whatever thin scattering exists on the void side thins further still. Far enough into the future, some careful calculations suggest an observer here might eventually look out into a sky holding meaningfully fewer visible galaxies than it does tonight, the deep fields of some distant future growing quieter rather than more crowded. That future is unimaginably far off, further than any number spoken tonight could usefully convey, but it is a fitting thought to end this chapter on. Even room this vast keeps slowly, patiently changing. This is as far up as tonight's climb carries any new ground. We have followed the ladder from breath to atmosphere, from atmosphere to star, from star to galaxy, from galaxy to the crowded field of galaxies beyond, and now to this, the long quiet at the edge of what astronomers can still describe with any confidence. Beyond here, the dark continues, the way the road continues past the last house, past the last light, but we do not need to keep naming what comes next. We have reached, for tonight, the edge of what we know how to call by name. Let the climb rest here a while, and let the quiet be what it is, wide and soft and unmeasured, more space than story, more room than reason. We have come a long way up, and the way up has, for now, run out of new things to say. Tonight began with a question a child could ask. What is directly above us? We climbed straight up to answer it. And now, settled and quiet, the answer is ready. It was never one thing, but a stack of quiets, resting one above the next, each layer holding the one below it without pressing down on it at all. Picture the climb again, softly, moving back down through it the way a hand might trail down a banister on the way to sleep. Above us first, closest of all, the thin sheet of stars we have always lived inside, the disk that looks like a hazy road on a clear night. Just past that, the older suspended cloud, drifting slower and dimmer than the disk it surrounds. Beyond that, the vast old halo, wide and sparse and patient. Scattered through it, the ancient lantern clusters, each one a small round gathering of old light. Around all of it, the faint breath of gas, thin enough to be almost nothing. And yet there, further still, the shape we could only weigh, felt rather than seen, holding the rest together by its quiet pull alone. Companion galaxies drifted near us through that same dark, small, and faithful, keeping pace the way a lantern keeps pace with the one who carries it. Two clear windows opened in the dust and let us look straight out. A far crowd, once mistaken for empty sky, resolved into its own gentle scatter of light. And beyond even that, The long, soft quiet, the space that asks nothing and answers nothing, simply holds. That is the list, and now let it go. Let each layer stop being a layer and become, instead, one single stillness, wider than the galaxy that started the climb, wider than any name we gave it along the way. It does not need to be counted anymore, only rested in. Feel, for a moment, how far beneath us the whole of that stack now rests. Not as distance to be afraid of, but simply as distance already traveled, already behind us, already done. The floor we began on, the one that once felt like the entire world, is only the lowest step of something we have since learned to see as one long, continuous ascent. Nothing about that first step was ever small. It only looked that way from underneath before the climb began. If any part of this drifted past too quickly to hold on to, that was always allowed. The stack does not need to be recited to be trusted. It simply needs to have been walked once, together, at whatever pace the night required, the way any long, gentle climb is allowed to blur a little in memory while still leaving behind the calm of having made it. Whatever of it stays with you by morning was always going to be enough, and whatever quietly slips away by then was only ever meant to be felt once, gently, tonight. None of what was described tonight was ever something to hold on to. Not the distances, not the order, not the names of the layers, or the shapes drawn around them. None of it was a test. It was only a way of standing still together for a while and looking straight up, the way a child might, without needing to explain what they were looking at. The scale was never the point. What mattered was the quiet underneath it. So let it all soften now. Let the disk and the cloud and the halo and the clusters and the gas and the unseen shape and the small companions and the two clear windows and the far crowd and the long quiet beyond all of it fold back down into a single dark, simple and unbroken, the same dark that was always there above the roof, above the trees, above the question itself. We do not need to carry any of it forward, only to have felt, once, how far up quiet can go and how gently it holds. Rest here. There is nothing left to climb, nothing left to name, nothing left to do but breathe and let the night close in around you like the soft ceiling it has always been. Good night, and gently, gently sleep.